What's up guys, and welcome back to my channel. So here we are talking about electricity, which is a part 2. Okay, we are discussing the electricity from the continuation of our first video of electricity. So in our first video we have discussed about the charges. Okay, we have discussed about the charges. So charges are two type. One is positive charge and another one is a negative charge. One is positive charge and another one is negative charge. As I said, unlike charges, it means one positive charge and one negative charge will always attract each other, and like charges, like positive charge and positive charge, or negative charge, if two like charges comes nearer to each other, they will try to go far away from each other. It means the repulsion will occur. It means they will repulse each other. So like charges always repulse each other, or unlike charges always attracts each other. So these are the charges which I have discussed in our previous video, and we have discussed electric current. Okay, electric current is denoted by the letter I. And what is the electric current? The number of charges passing through the cross section of area in per unit time. Okay, charges passing per unit time, it means charge per time is called electric current. Okay, so what will be the unit for electric current? So charge units is coulombs, and the units for time is seconds. In physics, coulombs per second is known as amperes, and it is denoted by the letter A. So the units for current is amperes. So the electric current is the number of charges passing through the cross section of area of the wire in per unit time. It means charge per time. So the unit for electric current is coulombs per second, that is nothing but amperes. The next thing we have discussed in our previous video is voltage. So the voltage is nothing but the work done on a charge to move from one place to the another place. So the voltage is denoted by the letter V, and the voltage is nothing but the work done per charge. The work done per charge is called the voltage. Whatever the force is applied by the electric field to the specific electron, it means electron is moving from one place to the another place. So by moving from one place to the another place, some work is done. So the voltage is defined as the work done per charge. The units for work done is joules, and the units for charge is coulombs. Okay, the unit for charge is coulombs, and the unit for work done is joules, and joules per coulombs is nothing but volts, which is denoted by the letter V. Okay, यहाँ पर voltage क्या होगा? Voltage is nothing but एक चार्ज पर कितना वर्क डन हुआ एक चार्ज पर, हम उसे कहेंगे वोल्टेज. और वोल्टेज के यूनिट्स क्या होंगे? वर्क डन के यूनिट्स है जूल्स, डिवाइडेड बाय चार्ज के यूनिट्स है कुलम्स. और फिजिक्स में जूल्स पर कुलम्स को हम कहेंगे वोल्ट्स. सो द यूनिट फॉर वोल्टेज इज वोल्ट्स, which is denoted by the letter V. After that we have discussed Ohm's law. Very, very important. Ohm's law is nothing but the voltage is directly proportional to the current when the temperature is constant. Okay, remember this. If you have a closed circuit like this, okay, if you have a conductor like this, if you connect this conductor to a battery, and then if you keep the temperature constant, ओके अगर आपके पास एक कंडक्टर है जो कि बैटरी से कनेक्टेड है, तो यहाँ पर अगर टेम्परेचर कांस्टेंट होगा, देन इफ यू इंक्रीज द रेट ऑफ वोल्टेज, देन ऑटोमेटिकली द रेट ऑफ करंट विल बी इंक्रीज्ड. इट मीन्स कि यहाँ पर जब एक टेम्परेचर कांस्टेंट रहेगा, सो voltage is directly proportional to the current produced in it when temperature is constant. Okay, the most important thing is temperature. Then we have टेकन दिस एक्सप्रेशन, ये एक्सप्रेशन देखिए V इज डायरेक्टली प्रोपोर्शनल टू I. अब कभी भी ओके वेर एवर इट मे बी we have to remove the proportionality sign. So here I'm removing the proportionality sign. So V is equals to, अगर यहाँ से proportionality की sign हट गई, so if I remove the proportionality sign, then I will get a constant, and that constant is denoted by R, and here I same as it is. This R is nothing but resistance. This R is nothing but resistance, which is denoted by the letter R. So what is the resistance? So here let us suppose conductor is here and the current is flowing in this direction. So the flow of current, okay, the obstruction which is faced by the flow of current, okay, every material have a property called resistance. Every material obstruct the flow of current. So the property of a material by which it obstructs the flow of current is called resistance. देखिए हर मटेरियल के पास एक प्रॉपर्टी होती है. वो प्रॉपर्टी का मतलब ये क्या होता है कि हर मटेरियल अपने थ्रू करंट का फ्लो रोकने की कोशिश करेगा, और वो जो रोकने की प्रॉपर्टी होगी हम उसे कहेंगे रेजिस्टेंस. सो एवरी मटेरियल हैव सम रेजिस्टेंस, okay, and the property of resistance and the amount of resistance is called resistivity, So the obstruction to the flow of current, okay, the obstruction to the flow of current is called resistance, and it is denoted by letter R. So we want the unit for resistance, so we have expression V is equals to Ri. Here R is equals to V by I. Okay, the units for voltage is volts, and the unit for current, this is I, it means current, so the unit for current is amperes. So volt per ampere is nothing but ohms, 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 and ohms is denoted by this sign. Okay, so resistance having the unit called ohms, it is denoted by this expression. Okay, so Ohm's law is nothing but the potential difference or voltage is directly proportional to the current when the temperature is constant. Okay, V is directly proportional to the I, then I am removing the proportionality sign, then a constant will be added, and that constant is nothing but R, which is resistance, and resistance is the obstruction to the flow of current. Every material have some amount of resistance, and it is denoted by the letter R. Okay, so I want the unit for resistance, so R is equals to V by I. V is voltage is having the units volt, and current is having the units ampere. Then volts per ampere is called ohms, and ohms is the unit for resistance. Whenever you are going to express some magnitude for resistance, you will express 5 ohms, 10 ohms, or 6 ohms, whatever the magnitude may be. Okay, so now resistance depend upon something. Okay, the first thing is resistance and length. Okay, if you consider a wire, okay, if you consider a wire having a length L, then resistance is directly proportional to the length of the wire. It means if you increase the length of the wire, then resistance will also increases. It means if you reduce the length of the wire, then automatically the resistance will also increases. Okay, so resistance is dependent upon the length of the wire, and resistance is directly proportional to the length of the wire. So it means R is directly proportional to L. Okay, call it as expression number 1. And this wire having cross-sectional area. Okay, this wire having a cross-sectional area as A. Okay, this wire having a cross-sectional area A. Then the resistance is inversely proportional to the cross-sectional area of the wire. It means if you increase the cross-sectional area of the wire, then resistance will get decreases, and if you decrease the cross-sectional area, then resistance will increases. Okay, what I mean to say is, अगर आपके पास एक कंडक्टर है जिसकी लेंथ है L और इसके पास क्रॉस-सेक्शनल एरिया है A, then पहली चीज तो ये होगी कि रेजिस्टेंस विल डायरेक्टली प्रोपोर्शनल टू द लेंथ ऑफ द वायर. इट मीन्स कि जितनी ज़्यादा लेंथ ऑफ द वायर होंगी उतना ज़्यादा रेजिस्टेंस होगा, और जितनी लेंथ वायर की कम होगी उतना कम रेजिस्टेंस होगा. एंड द सेकेंड थिंग इज resistance is inversely proportional to the area of the cross section of the wire. It means कि अगर आप एरिया को बढ़ा देंगे यानी क्रॉस सेक्शनल एरिया ऑफ द वायर को बढ़ा देंगे देन रेजिस्टेंस वहां पर डिक्रीज हो जाएगा, रेजिस्टेंस वहां पर कम हो जाएगा. अगर आप क्रॉस सेक्शनल एरिया कम कर देंगे देन वहां पर रेजिस्टेंस इंक्रीज हो जाएगा. ओके, सो आर इज इनवर्सली प्रोपोर्शनल टू एरिया ऑफ द क्रॉस सेक्शन. कॉल इट एज एक्सप्रेशन नंबर 2. Then equating these two equations we will get R is directly proportional to L and inversely proportional to cross sectional area. Then I'm merging these two expression. अब यहाँ पर इन दोनों को मिलाने के बाद R is directly proportional to L by A. Okay, R is directly proportional to L by A. As I say, we have to always remove the proportionality sign. Okay, so here R is equals to, if I remove this proportionality sign, I will get a constant as rho L by A. Okay, and this rho is called resistivity. This rho is called resistivity or specific resistance Getting my point? This rho is called resistivity or specific resistance. So I want the unit for rho. So here R is equals to rho L by A. A will get here, so R into A by, and this L will get into the denominator. RA by L is equals to rho. Then the units for resistance is ohms, and the area units are meter square divided by length units are meter is equals to rho. Meter will get cancelled, then rho is equals to ohm meter. So the units for specific resistance is ohm meter. Okay, so till here we have discussed in our previous video. So hope you understood the concept. So I hope you understood the concept. So let's move forward. Okay, so the next topic is always remember Ohm's law. Okay, what is the Ohm's law? V is directly proportional to the current, okay, at constant temperature. Then if I'll remove this proportionality sign, I will get V is equals to Ri. Okay, this is the one of the main formula. Then similarly from this expression I can get R is equals to V by I. Then similarly from this equation I will get I is equals to V by R. I is equals to V by R. These three things you have to remember. Okay, these three things you have to remember. V is equals to Ri or IR, or V is equals to IR, and then R is equals to V by I and I is equals to V by R. These things you have to know. So coming from Ohm's law, based on Ohm's law, the conductors are divided into two types. Okay, based on Ohm's law, conductors are classified into two types based on Ohm's law. Okay, so the conductors are divided into two categories. First one is ohmic conductors. Very, very important for the exam point of view. Okay, first one is ohmic conductor and the second one is non-ohmic conductors. Based on Ohm's law, we will classify conductors into two types: ohmic conductors and non-ohmic conductors. So coming up to the ohmic conductors, the conductors which obeys Ohm's law, is known as ohmic conductor. What I mean to say is the conductors which follow Ohm's law. It means you increase the voltage, automatically the current will be increases at constant temperature. Ohmic conductor यहाँ पे क्या है? ऐसे conductors जो Ohm's law को follow करते हो. It means ऐसे कंडक्टर्स जिसमें अगर आप वोल्टेज का रेट इंक्रीज करेंगे देन ऑटोमेटिकली करंट का रेट इंक्रीज होगा एट कांस्टेंट टेम्परेचर पर. सो ऐसे कंडक्टर्स जो ओम्स लॉ को फॉलो करते हो हम उसे कहते हैं ओमिक कंडक्टर्स. So I am repeating again, the conductors which obeys Ohm's law is called ohmic conductors. Okay, get my point? The conductors which obeys Ohm's law is called ohmic conductors. So यहाँ पर examples all pure metal, examples are pure metals like copper and aluminium, so on. Okay, pure metals which obeys Ohm's law is called ohmic conductor. Okay, this is the definition, but actually mathematically ohmic conductors can be identified as by the VI graph. Okay, we have VI graph like this. We have VI graph like this, VI. So for ohmic conductors, the VI graph is linear like this. Okay, the ohmic conductors have the VI graph like this. VI graph for ohmic conductors is linear and starts from origin. Okay, this is the origin, and the graph for VI is linear and start from origin. Okay, so once again, what are the ohmic conductors? Conductors which obeys Ohm's law is called ohmic conductors. Okay, so ohmic conductor ऐसे conductors होते हैं जो Ohm's law को obey करते हैं. It means अगर आप वो conductors में constant temperature पर voltage का rate increase करेंगे, then automatically current का rate increase होगा at constant temperature पर. So वैसे conductors को हम कहेंगे ohmic conductors. So ohmic conductor से example है pure metals, copper, like copper and aluminium, etc. And one thing you have to remember, the VI graph for ohmic conductors, always the VI graph for ohmic conductors is linear and always it starts from origin. Hope you understood. Then coming up to the non-ohmic conductor, the conductors which does not obey Ohm's law, with the conductors which does not obeys Ohm's law. Okay, the conductors which does not obeys Ohm's law are called non-ohmic conductors. ऐसे कंडक्टर्स जिनका टेम्परेचर कांस्टेंट रखने पर भी वोल्टेज का रेट अगर आप इंक्रीज करेंगे देन करंट का रेट वहां पर इंक्रीज नहीं होगा, वैसे कंडक्टर्स को हम कहेंगे नॉन ओहमिक कंडक्टर्स. व्हाट आर दे कॉल्ड? नॉन ओहमिक कंडक्टर्स. सो द नॉन ओहमिक कंडक्टर्स, द एग्जांपल फॉर नॉन ओहमिक कंडक्टर्स आर डायोड्स, triodes, okay, and vacuum tubes also are the example for non-ohmic conductors. Okay, non-ohmic conductors are nothing but the conductors which does not obeys Ohm's law. Okay, remember this definition only, it will ask in your 1 mark. Okay, the conductors which does not obey Ohm's law is called non-ohmic conductor. And based on VI graph, I have described the ohmic conductor. So likewise, the VI graph for non-ohmic conductors, okay, this is the VI origin, and the VI graph for non-ohmic conductor is not linear. Okay, is not linear. VI graph for ohmic conductors is not linear. What I mean to say is कि ऐसे कंडक्टर्स जो ओम्स लॉ को ओबे नहीं करते हम उसे कहते हैं नॉन ओहमिक कंडक्टर्स, जैसे डायोड्स, ट्रायोड्स और वैक्यूम ट्यूब. ओहमिक कंडक्टर के लिए VI ग्राफ, ओहमिक कंडक्टर के लिए VI ग्राफ लीनियर होगा और ओरिजिन से स्टार्ट होगा, और नॉन ओहमिक कंडक्टर के लिए VI ग्राफ लीनियर नहीं होगा. इट मींस इट डजंट हैव अ स्ट्रेट लाइन फ्रॉम ओरिजिन. सो VI ग्राफ नॉन ओहमिक कंडक्टर्स के लिए लीनियर नहीं होगा, और ऐसे कंडक्टर्स जो ओम्स लॉ को ओबे नहीं करते हैं हम उसे कहते हैं नॉन ओहमिक कंडक्टर्स. होप यू अंडरस्टूड द कॉन्सेप्ट. ओके, एंड नेक्स्ट थिंग इज temperature coefficient of resistance. The next thing is temperature coefficient of resistance. I will write down the side heading. Temperature coefficient of resistance. Temperature coefficient of resistance. So यहाँ पर temperature coefficient of resistance. So the definite आप इतना समझिए temperature coefficient of resistance क्या होता है? What does it mean? The factor by which the resistance of the material change with temperature. I will write down. You will get understand easily. So the factor by which the resistance of the material change with temperature is called temperature coefficient of resistance, TCR. Okay, so what does it mean? Temperature coefficient of resistance, the factor by which the resistance of the material changes with temperature is called temperature coefficient of resistance. So any factor means any reason by which the resistance of the material changes with temperature. Okay, so when the temperature changes, obviously the resistance changes, because here one more also relation. If we increase the temperature of the conductor, automatically the resistance will increases. So any reason by which the resistance of the material changes with temperature. If we change the temperature, then obviously the resistance will changes. So the factor is called the coefficient of resistance, or else you can say it is the measure of resistance. Okay, the change in resistance, you can say change in resistance per degree rise in temperature, You can also define temperature coefficient of resistance as change in resistance per degree rise in temperature. How many resistance is getting increased per rise in temperature? Nothing but temperature coefficient of resistance. Okay, let me explain you clearly. Okay, so pay attention here. For example, I have a conductor. Its initial resistance is R1 and its initial temperature is T1 degree. Okay, T1 degree. Now I am heating this conductor, then its temperature will get changes to T2 degree, and its obviously its resistance will get obviously increase. It means R2. Okay, मैं यहाँ पर एक कंडक्टर कंसिडर कर रहा हूँ जिसका रेजिस्टेंस है R1 और जिसका टेम्परेचर है T1 डिग्री, और इस कंडक्टर को हीट करने के बाद जाहिर सी बात है कि इसका टेम्परेचर चेंज होगा, और जो चेंज होने वाला टेम्परेचर है मैं उसे कह रहा हूँ T2 डिग्री सेल्सियस, और रेजिस्टेंस विल आल्सो चेंजेस, और रेजिस्टेंस यहाँ पर भी चेंज होगा। देन जो रेजिस्टेंस चेंज हो रहा है मैं उसे कह रहा हूँ R2। सो यहाँ पर चेंज इन रेजिस्टेंस हो जाएगा R2 माइनस R1, चेंज इन रेजिस्टेंस हो जाएगा R2 माइनस R1, और चेंज इन टेम्परेचर है T2 माइनस T1। चेंज इन रेजिस्टेंस है R2 माइनस R1, चेंज इन टेम्परेचर है T2 डिग्री माइनस T1 डिग्री सेंटीग्रेड। सो यहाँ पर द चेंज इन रेजिस्टेंस it means R2 minus R1, the change in resistance is directly proportional to R1. It means जितना भी रेजिस्टेंस में चेंज होगा वो डायरेक्टली प्रोपोर्शनल होगा इनिशियल रेजिस्टेंस के। ओके, और द चेंज इन रेजिस्टेंस इज डायरेक्टली प्रोपोर्शनल टू चेंज इन टेम्परेचर। ओके, जितना चेंज रेजिस्टेंस में होगा वो डायरेक्टली प्रोपोर्शनल होगा चेंज इन टेम्परेचर के। इट मीन्स जितना चेंज होगा टेम्परेचर के डिफरेंस में उतना ज़्यादा चेंज होगा रेजिस्टेंस के डिफरेंस में। ओके, सो आप बस इतना याद रखिए, यू रिमेंबर ओनली दिस, द चेंज इन रेजिस्टेंस इज डायरेक्टली प्रोपोर्शनल टू initial resistance, and change in resistance is directly proportional to change in temperature. Now I'm mixing these two conditions, R2 minus R1 directly proportional to R1 into T2 degree minus T1 degree. Okay, now everywhere we have to remove this proportionality sign. For removing the proportionality sign here, so removing the proportionality sign, I am adding a constant here. So R2 minus R1 is equals to, here the proportionality sign will be get removed and I have to add a constant. I have to write a constant, that is alpha. That is alpha. Here the term is R1 into T2 minus T1. R1 into T2 degree minus T1 degree centigrade. So now listen carefully. R2 is equals to, here minus R1 will go their side, it will become plus R1. R1 plus alpha into R1 T2 minus T1 degree centigrade. So here I can take R1 common. So R2 is equals to, I have taken R1 common, then here 1 will get remains, so alpha into T2 minus T1 degree centigrade. T2 minus T1 degree centigrade. So now this expression indicates their temperature dependence of resistance. Okay, this expression, this equation express the temperature dependence. The temperature dependence of a resistance, ओके जो ये एक्सप्रेशन हमको मिला, ये एक्सप्रेशन हमें बताता है कि टेम्परेचर कितना डिपेंड होता है, सॉरी रेजिस्टेंस कितना डिपेंड होता है टेम्परेचर पे. ओके सो नाउ अब यहां पर देखिए, हियर आई विल गेट, अब यहां पर मुझे कोएफिशिएंट ऑफ रेजिस्टेंस मालूम करना है. सो यहां पर देखिए आई विल सेंड R1 टू दिस साइड, सो R2 माइनस R1 is equals to 1 plus alpha into T2 minus T1 into T2 minus T1. अब यहाँ पर into T2 minus T1. So here R2 minus R1 divided by R1 into T2 minus T1. So this is the expression for the coefficient of resistance. Temperature coefficient of resistance alpha is equals to R2 minus R1 divided by R1 into T2 minus T1. This expression and this coefficient of this temperature coefficient of resistance you have to know. Okay, so this is all about temperature coefficient of resistance. Hope you understood the concept. Okay, so the next topic is combination of resistors. Okay, one of the most interesting and important topic in electricity. I'm talking about in electricity. So combination of resistors. So the combination of resistors mean the arrangement of resistors. So arrangement of resistors can be of two types. The first one is series combination. And another one is parallel combination. First one is series combination, another one is parallel combination. Okay, so series combination. Okay, what does it mean by series combination? For example, here I am considering resistors like this. I am arranging resistors like this. What does the series combination of resistors mean is, if different resistors are joined together such that there is only one path for the flow of electric current. Okay, I have arranged these resistors in such a way that there is only one path for current to flow. मैं देखिए सीरीज कॉम्बिनेशन का मतलब ये है कि मैं रेजिस्टर्स को कुछ ऐसे तरीके से अरेंज करूंगा जहां पर सिर्फ करंट के लिए एक ही डायरेक्शन हो फ्लो करने का. जहां पर करंट के लिए सिर्फ एक ही डायरेक्शन हो फ्लो करने के लिए, अगर मैं उस अरेंजमेंट में रेजिस्टर्स को अरेंज कर दूंगा, देन ये अरेंजमेंट को कहते हैं सीरीज कॉम्बिनेशन ऑफ रेजिस्टर्स। सीरीज कॉम्बिनेशन ऑफ रेजिस्टर्स, यहां पर ये सीरीज कॉम्बिनेशन ऑफ रेजिस्टर्स में always you remember in series combination the current is same, I is same, okay, because the current is flowing in only one direction, okay, the current is same, but the voltage is different. Voltage is different because the resistors have different value, okay, it will be 2 ohms, it will be 5 ohms, it will be 6 ohm or 7 ohm, any magnitude may be, okay. Resistors have the voltage is depend upon the value of resistance, so depending upon the value of resistance the voltage is different in series combination, okay. Voltage is different in series combination, okay. So one thing should be clear, the series combination, in series combination the resistors are arranged in such a way that there is only one path for electric current to flow, okay. series combination है क्या, सिंपल वे में समझाता हूँ कि series combination में हम resistors को ऐसे arrange करते हैं कि जहाँ पर current के लिए सिर्फ एक ही direction of flow होने का, और वहाँ पर series combination में current same होता है, current is same और वोल्टेज इज डिफरेंट, ओके। वोल्टेज इज डिफरेंट क्योंकि रेजिस्टर्स की वैल्यू अलग अलग होती है, ओके। हर रेजिस्टर्स के लिए कुछ अलग वोल्टेज लगता है, सो वोल्टेज डिफरेंट होता है और करंट सेम रहता है सीरीज कॉम्बिनेशन में, ओके, सीरीज कॉम्बिनेशन में। देन कमिंग अप टू द पैरेलल कॉम्बिनेशन, ओके, देन कमिंग अप टू द पैरेलल कॉम्बिनेशन, पैरेलल कॉम्बिनेशन वुड बी लुक लाइक दिस। So this is the parallel combination looks like. So यहाँ पर देखिए, look carefully here, the current will be passed from positive terminal come here and at this point the current is divided into branches, okay। देखिए parallel combination में current बैटरी से आएगा and ये point पर आने के बाद current divide हो जाएगा, okay। It means current is divided in parallel combination of resistors, okay। The thing is to know that current is divided but the voltage is same, here in series connection, here in series combination current is same, voltage is different, but in parallel combination current is divided, it means the current is not same for the resistors and but the voltage is same। देखिए सीरीज कॉम्बिनेशन में करंट सेम है और वोल्टेज डिफरेंट है, इन पैरेलल कॉम्बिनेशन में करंट डिवाइड होता है और वोल्टेज सेम रहता है। सो अब यहाँ पर सीरीज एंड पैरेलल कॉम्बिनेशन समझने के बाद सीरीज एंड पैरेलल कॉम्बिनेशन में हमको फाइंड करना है equivalent resistance, okay। There are so many resistance, okay। We can't say the value of resistance is so much, but we can say the equivalent resistance, approximate resistance। So for in series combination the approximate resistance or equivalent resistance, okay, equivalent resistance, okay, let's upon that current through the resistors, yes, equivalent resistance यहाँ पर सीरीज कॉम्बिनेशन में इक्विवेलेंट रेजिस्टेंस पूरे रेजिस्टेंस को सम करने पर मिलता है। इट मींस अगर आप पूरे रेजिस्टर्स की वैल्यू को ऐड कर देंगे देन यू विल गेट द इक्विवेलेंट रेजिस्टेंस। फॉर एग्जांपल ये रेजिस्टर है R1, ये रेजिस्टर है R2, ये रेजिस्टर है R3। सो मुझे होना है आई वांट इक्विवेलेंट रेजिस्टेंस यानी R इक्विवेलेंट, सो आई विल ऐड R1 प्लस R2 प्लस R3 इन सीरीज कॉम्बिनेशन। सो equivalent resistance in series combination is R1 plus R2 plus R3, R1 plus R2 plus R3 in series combination, in series combination, because resistors are arranged in such a way that there is only one path for current to flow. Okay, याद रखिए हमेशा के सीरीज कॉम्बिनेशन में इक्विवेलेंट रेजिस्टेंस हमें पूरे रेजिस्टर के वैल्यू को ऐड करने पर मिलता है. ओके, सो इफ दिस arrangement have 3 resistors, then R1 plus R2 plus R3. 4 resistors, R1 plus R2 plus R3 plus R4. 5 resistors, R1 plus R2 plus R3 plus R4 plus R5. Then if there is an n number of resistors in series connection, then R equivalent is equals to R1 plus R2 plus R3 plus so on to Rn. Okay, if just remember, in series combination the equivalent resistor is found by adding all the value of resistance. Okay, in case of parallel combination, suppose this is R1, R2 and R3. So in case of equivalent resistance, the formula is 1 by R equivalent is equals to 1 by R1 plus 1 by R2 plus 1 by R3. This is the expression for parallel combination. So example, such there is the two resistors. If there is two resistors arranged in the parallel combination, okay, if there is two resistors arranged in the parallel combination, so this resistor is R1, another resistance is R2. So the equivalent resistance, it means 1 by R equivalent will become 1 by R1 plus 1 by R2. So 1 by R equivalent is equals to cross multiplication R1 1 into R1 plus 1 into R2 divided by R1 into R2. I want R equivalent, not 1 by R equivalent. So R equivalent is equals to, I am flipping this, automatically this term will also get flipped. So R equivalent is equals to R1 into R2 divided by R1 plus R2. This thing will gonna used when you have two resistors in parallel combination. This expression will works only if you have two resistors in parallel connection. Okay, if you have 3 resistors, 1 by R1 plus 1 by R2 plus 1 by R3. 4 resistors in parallel, 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4. Okay, if two resistors are connected in parallel combination, then the equivalent resistance R equivalent is equals to R1 into R2 divided by R1 plus R2. So this is the series and parallel combination. Okay, let me explain you once again. In series combination, the resistors are arranged in such a way that there is only one path for current to flow. Series combination में हम resistors को ऐसे arrange करते हैं जिसमें current के लिए सिर्फ एक ही direction होता है flow होने के लिए, और वहां पर equivalent resistance पूरे resistances को add करने पर मिलता है. It means R1 plus R2 plus R3. Then coming up to the parallel combination में करंट यहां पर आने के बाद डिवाइड होता है और सबके लिए वोल्टेज सेम होता है. और इक्विवेलेंट रेजिस्टेंस पैरेलल कॉम्बिनेशन के लिए 1 by R इक्विवेलेंट इज इक्वल्स टू 1 by R1 plus 1 by R2 plus 1 by R3. Then if two resistors are arranged in parallel combination, then equivalent resistance is equals to R1 into R2 divided by R1 plus R2. So this is series and parallel combination. Okay, you will get some numerical problems on series and parallel combination. Okay, let me do some numericals on series and parallel combination. So you will get circuit diagram, and in an exam they will say find the equivalent resistance, find voltage, find current through each resistors. We will see it in the problems. So doing the first problem, okay, and this is 2 ohms, 3 ohms, 5 ohms. The battery and the voltage is 12 ohms. Okay, 12 ohms. Then the question, the first bit is find equivalent resistance. Take a notebook and a pen and note down what I am telling to you, because this is the numeric, this is not a theoretical subject. Okay, अब मैं जो भी चीज़ें मैं आपको बता रहा हूँ, just take a notebook and note it down. और जितने भी आपको problems करा रहा हूँ, अगर आपको वो problems से familiar है, so just pause the video and try it on your own. So the first bit is find equivalent resistance. The second bit is find total current. Find total current through each resistors. Find the total current through each resistor. So here the first thing he is asking to find equivalent resistance. Okay, equivalent resistance, it means he is asking R equivalent. So in series combination we get equivalent resistance by adding all the value of resistors. Okay, so consider this resistor is R1, this resistor is R2, and this resistor is R3. Then the equivalent resistance in series combination will become R1 plus R2 plus R3. Okay, R1 plus R2 plus R3. So R equivalent is equals to R1 2 ohms plus 3 ohms plus 5 ohms. 2 ohms plus 3 ohms plus 5 ohms. So how much we get? R equivalent is equals to 2 plus 3, 5 plus 5, 10 ohms. Okay, we get the equivalent resistance as 10 ohms. So here the first bit is completed. Second bit is to find the total current through each resistors. Okay, we have to find the current through R1, through R2 and R3. So we have a relation. Okay, to find the current through each resistor we have a relation, V is equals to IR. Okay, we want the value of current, then I is equals to V by R. So here I is equals to V by R. Here we don't have a single resistance value. Okay, we have 2 ohms, we have 3 ohms, we have 5 ohms. So while finding the current in series combination, we should consider equivalent resistance. Then I is equals to, what is the voltage here? Sorry, this is voltage 12 volts. Okay, 12 volts V. So 12 divided by R equivalent. R equivalent is 10. Okay, 10. Then I is equals to what is the current? 1.2 amperes. 1.2 amperes. Okay, the second bit is also get completed. Here in the question he asked to find equivalent resistance. So how we get the equivalent resistance? यहाँ पर हम equivalent resistance कैसे find करेंगे? In series combination में हमेशा याद रखिए, series combination में equivalent resistance हमेशा पूरे resistance को add करने पर आता है. It means we will gonna add R1, R2 and R3, so we will get equivalent resistance. So similarly I have did like this: R1 2 ohms plus R2 3 ohms plus R3 5 ohms. 2 ohms plus 3 ohms plus 5 ohms will give equivalent resistance as 10 ohms. Okay, the first bit is completed. Second is find total current through each resistors. Okay, he asked to find the total current. So we have a relation as Ohm's law, V is equals to IR. From this relation I get I is equals to V by R. But here I have get I is equals to V by R. Here R means the single resistance. But I don't have a single resistance. Okay, I have 2 ohms, I have 3 ohms, I have 5 ohms. Okay, what I mean to say is कि यहाँ पर relation में है I is equals to V by R. V by R का मतलब है एक सिंगल रेजिस्टेंस. ओके, यहाँ पर सीरीज कॉम्बिनेशन में एक सिंगल रेजिस्टेंस नहीं है. ओके, यहाँ पर है 2 ohms, 3 ohms, 5 ohms. Then we should have to consider always when you are going to find a current in series combination, you have to consider equivalent resistance. Equivalent resistance we got as 10 ohms and the voltage is 12 volts. So I is equals to 12 by 10. We get 1.2 amperes. Okay, 1.2 amperes. Okay. This is the series combination problem. The next one is, okay, just practice and practice. Okay, I will show up some problems, and you should have to try the problems by seeing in your textbook. Okay, just see the question and close up the textbook and just try on your own. So the next question is, the circuit diagrams look like this. The circuit diagram is look like this, plus minus. Okay, so here 10 volts of current, 10 volts of voltage, so current is flowing like this. Okay, I current is flowing, then at this branch the current will be divided. Okay, the value for resistance is 1 ohms, 2 ohms, 3 ohms. 1 ohm, 2 ohm and 3 ohms. The current which is going here, I am calling it as I1. The current which is flowing here at 2 ohms resistors, I will call it as 2 ohms, I2, and the current which is flowing here, I will call it as I3. So the first question, he is asking to find the equivalent resistance. Find the equivalent resistance. Find the equivalent resistance. The second thing is asking find the current. Find the current flowing. Find the current flowing through. Find the current flowing through 3 ohms resistor. Find the current flowing through 3 ohms resistor. So the first bit is to find the equivalent resistors. So here the resistors are arranged in a parallel way. Okay, 1 upon 1, 1 upon 1, they are arranged like that. So this is the parallel connection. This is the parallel connection of resistors. So यहाँ पर देखिए, the first bit is to find the equivalent resistance. Okay, the first thing is to find equivalent resistance. So how can I find the equivalent resistance when the resistors are arranged in a parallel connection? I have written one for expression that 1 by R equivalent is equals to 1 by R1 plus 1 by R2 plus 1 by R3. 1 by R1 plus 1 by R2 plus 1 by R3. So consider this as resistance 1 R1, this as R2 and this as R3. Okay, this is the parallel connection. ये parallel connection है, तो equivalent resistance 1 by R equivalent is equals to 1 by R1 means 1 by 1. 1 by 1 plus 1 by R2 means 1 by 2 plus 1 by R3 means 1 by 3. Okay, 1 by 3. Then 1 by R equivalent. 1 by R equivalent, just wait, I am calculating. 1 by 1 plus 1 by 2 plus 1 by 3. I am getting as 11 by 6. 11 by 6. So how can I, how I'm getting 11 by 6? Look at here, 1 into 2 is 2. The LCM would be, I'm calculating here, 1 by 1 plus 1 by 2 plus 1 by 3. So the LCM is 1 2s are 2, 2 3s are 6. So 1 6 are 6, 1 6 are 6, 1 3s are 2 3s are 3, 1 3s are 3, 3 2s are 3, 3 2s are 3. So 6 plus 3 plus 2. So 6 plus 3, 9, 9 plus 2, 11 by 6. Okay, 11 by 6. So I want R equivalent. I want R equivalent. So I will flip this R equivalent. It will become like this. Okay, I am flipping this R 1 by R equivalent. Then it will become R equivalent. So here 11 by 6 will also get flipped, and this will become 6 by 11. Okay, 6 by 11, and 6 by 11 is nothing but 0.515. So R equivalent is 0.51 ohms. 51 ohms. Here we get the equivalent resistance. Our first bit is completed. Then the second bit is to find the current flowing through 3 ohms resistor. Okay, here as I said, the current is getting divided as I1, I2, I3. Here the current which is flowing through 3 ohms resistors is I3. So we have to find I3. Here second bit I am calculating. I have to find I3. So we have a relation called V is equals to IR. Okay, V is equals to IR. We have to find I. So I is equals to V by R. I is equals to V by R. Always consider in series combination or in parallel combination, the resistance should be equivalent resistance. Okay, you should consider equivalent resistance. Then I is equals to what is the voltage? 10 divided by R equivalent is 0.15. Then I is equals to 10 by 0.15. It is 66 point, okay, 10 by 0.15. V by R 0.15. Sorry, 0.51. I think 0.51. It is becoming 19.6 amperes. Okay, I get the value of current as 19.6 amperes. Okay, the first bit is to find equivalent resistance. First bit यहाँ पर equivalent resistance find करना था. So expression for equivalent resistance is 1 by R equivalent is equals to 1 by R1 plus 1 by R2 plus 1 by R3. So 1 by R equivalent is equals to 1 by R1, that is 1 by 1, plus 1 by R2, that is 1 by 2, plus 1 by R3, that is 1 by 3. I have simplified this. I get 11 by 6. Then I flipped 1 by R equivalent. It has become R equivalent. Then it also get flipped 6 by 11. Then 6 by 11 is nothing but 0.51. So 0.51. So now here I want the current flowing through 3 ohms resistance. Okay, look at, find the current flowing through 3 ohms resistor. Here we have a relation V is equals to IR. We want current I. So I is equals to V by R. Then I is equals to, what is the voltage? 10 volts. So 10 divided by R equivalent is 0.51. Okay, 0.51. Then I is equals to 10 by 0.51 is 19.6 amperes. 19.6 amperes. So this is how you have to calculate the parallel combination. Sometimes it will mix series and combination, and parallel combination also. Okay, you sometimes you may get series combination separately, parallel combination separately, but in sometimes it will ask like the combination of both series and parallel. Okay, बास वक्त आपको series separate पूछ सकता है, आपको parallelly separate पूछ सकता है. Similarly कभी कभार, ओके, नॉट कभी कभार, इट में आस्क, ओके, ये आपको पूछ सकता है सीरीज और पैरेलल, ये दोनों मिक्स करके आपको बोलेगा कि फाइंड इक्विवेलेंट रेजिस्टेंस. लेट्स सी दैट. ओके, आई हैव अ सर्किट लाइक दिस. आई एम, सो क्वेश्चन, सो दिस इज माय सर्किट. This is my circuit. Plus minus, the current is flowing here and the current is will get divided here. Okay, so this is 5 ohms, this is 3 ohms, and this is 6 ohms. So find the question he is asking to find. Directly is asking to find equivalent resistance. So first we have to observe that which connection of resistors are in parallel or series. Okay, so look at here. First look at here, this part. Look at this part. This part is in the connection of which connection? Parallel combination. This is the parallel combination and this is the series. It means only one resistance is there. So यहाँ पर देखिए आप, ये है parallel combination. First आपको calculate करना होगा parallel combination, और जो भी parallel combination का आंसर आएगा आप इस resistor से उसे add कर देंगे. So first you have to solve the parallel combination. So for parallel combination, R equivalent is equals to 1 by R equivalent is equals to 1 by R1 plus 1 by R2. Okay, 1 by R1 plus 1 by R2. Here 1 by R equivalent is equals to R1 into 1, R1 plus R2 into 1, R2 divided by R1 into R2. So I am flipping 1 by R equivalent. So मैं ये 1 by R equivalent को flip कर रहा हूँ. So R equivalent बन जाएगा वो, और साथ ही जब 1 by R equivalent flip होगा then ये भी term जो है flip हो जाएगा. It will become R1 into R2 divided by R1 plus R2. So consider this as R1 and this as R2. So R equivalent is equals to R1 into R2 means 3 into 6, 3 into 6 divided by R1 plus R2 means 3 plus 6, 3 plus 6. So R equivalent is equals to 3 6 are 18 plus 3 plus 6 9, 9 was a 9, 9 2 are 18. So R equivalent is equals to 2 ohms. I get the parallel combination equivalent resistance as 2 ohms. Okay, 2 ohms. Still I don't get the total equivalent resistance. So for getting total equivalent resistance, I have to add this resistance and this resistance. So 5 plus 2 ohms will give the total equivalent resistance. So equivalent resistance is equals to 5 ohms plus 2 ohms. So R equivalent is equals to 5 plus 2 will become 7 ohms. So the equivalent resistance of this connection is 7 ohms. Hope you understood the concept. So this is all about the electricity part 2, जिसमें हम डिस्कस किए temperature dependence of resistance or temperature coefficient or series and parallel combination. So for getting perfect in this type of connection, just practice the several problems in your notebook or textbook or any site for this topic. Just search electricity series and parallel combination problem numericals. It will give a lot of numerical. Just solve it. Okay, देखिए जितने आप ज़्यादा प्रॉब्लम सॉल्व करेंगे उतना आप परफेक्ट होंगे. ओके, एवरीथिंग नीड्स प्रैक्टिस बिकॉज प्रैक्टिस मेक्स अ मैन परफेक्ट. सो कभी भी आपको किसी भी चीज़ में परफेक्ट होना है, सो जस्ट गो थ्रू दैट थिंग, उसे प्रैक्टिस करिए, नंबर ऑफ प्रॉब्लम्स सॉल्व करिए, देन यू विल गेट परफेक्ट. ओके, आई हैव ऑल्सो डन लाइक दिस. मैं भी जो है बहुत सारे न्यूमेरिकल सॉल्व किया हूँ सीरीज में, न्यूमेरिकल्स में, देन आई एम एबल टू शो यू. ओके, सो लाइक दैट आप just you sitting here and saying that I can do perfectly. It is not like that. You have to do something by your own. So what you have to do is just practice a lot of problem from your textbook, or you get anything. Okay, from you get anywhere you will get problem. Just go through that problems and practice it. Okay, so for till that, take care and stay motivated towards your studies. Stay focused and kindly subscribe my channel if you understand my concept. If you understand what I have expressed, just hit a like button and kindly subscribe and share my video. Okay, then take care, stay motivated, stay happy. God bless you all and Khuda Hafiz.